ready to dive right back into this mess that we made yesterday. Switch my screen. Everything looks good. Okay. Right, so where were we? I had just reset a bunch of changes I had made, right? Because we were in the middle of trying to get this, and this doesn't build, right? Cargo, check. Yeah, because we need to implement hash for something. This is unused. We know that. Cannot find trait hasher in this scope. Oh, right. We were in the middle of what did we do here? I changed that, and then we changed all of these to be RCs. Right. And we were going to make Expr into a hash, right? Oh, right. And the other thing I wanted to do was change these to RCs as well. So let's actually do that in code in the generator. So before we do anything else, let's So yeah, all of these need to be RCs because I was thinking about this in our interpreter. Oops, in our resolver. Oh, that's right. All the tests need to be fixed. What was it? Locals, locals. Yeah, this line here needs to have an RC. Ampersand RC or just regular RC? And then, yeah, just regular RC. In order to support that, we were going to implement RC, not RC, just this there. And we don't have hasher, right? So we need to add hasher. Okay, I think we're on the right track here. So let's do this. And then this. I just ran out of brain power yesterday. All right, and then we implement the hasher here, and then we also have to implement equals, right? Oh, all of these need to change? Okay. Ampersand RC. I can do that pretty easily. And then this, can that still stay like that, or does that have to change? Right, and then our code has to change. Expr. And then statement. Same thing. And hopefully this will be the right change to make here. Oh. And those aren't used anywhere, so it doesn't matter. And now this is not the right type. Right? And this is not the right type. Okay. Oh. So this does need to be this. Ooh. Yeah, okay. And resolve statement needs to, yeah, okay. And then init, where's init? Init.clone maybe should do the trick. Because we're just cloning the RC, so it's not that big of a deal. We're almost done. Still 37 errors. Oh, and then all of these need to change. Okay. I'm going to get out of this then. Git checkout dot. All right. Cleaned. We have to implement the hasher, and we have to implement the yeah, so let's do a quick build here just to make sure everything's clean. RM cargo clean, cargo build. SuperCuber, hi. I'm still struggling my way through this this chapter 11. I know you finished all the JLock stuff, right? You got that all working. I just need to get this working just for my own sanity here. So let's comment this out again. So, okay. And that way we can hack up an interpreter. Oh, right. I had commented this out. So locals. And then where is locals? Yeah, okay. So I wanted to make this an RC. Yeah, I got to resolving. There's probably a better way to do the resolving, but I'm still following the book. So, you know, it'd be nice is to write, you know, maybe part 4 in this book and make this. Oh, here's how you would do it in Rust, in a Rust way, because this is very much still a Java thing that I'm doing here. So I want to have this be an RC Expr. SuperCuber says RC ref cell environment is what I ended up with. Yeah, I have that for globals, and then I added an extra ref cell here so that I could do the replace environment. Replace. So in the execute block, I can swap it out for a new environment. I could just use the replace method that's on the ref cell, swap it out, and then swap it back afterwards. There's probably a better way to do it, but that's the way I solved it. Right, so I wanted RC Exprs in here. SuperCuber says I did a mem swap dance with an empty end. Oh yeah, mem swap. Do you have to wrap that in unsafe, or is that okay to use just directly? This RC Expr. Oop, this should be commented out. Okay, and now I can't do it because we don't satisfy that. Right, and this is where I was going to go over to our Expr code and add in, what was it, standard hash. Hash and hasher. And I'm just going to hack this in for now, but then we'll have to modify the generator code. SuperCuber says, nope, it's safe. Okay, it's safe to do mem swaps. Nice. Impl hash for Expr. And please, Rust, just tell me what I need to implement. So it's just this. And I'm going to stub it out like this for now, just to get it working. All right, so that should implement that, and now we should have EQ. Yep, okay, so EQ now needs to be, oops. Source Expr. So we should be able to say impl partial EQ for Expr, and I think this is just fn EQ, self and other, self returns a bool, and we'll just, oops, put a false in there just to stub it out. and then we have to, because we need EQ, like this for Expr. And that doesn't take anything. Okay, so this builds. Now the trick is to actually get this to work. And that's where I wanted to put RCs in here. So I could compare the references. Like that. And now this, what is this going to break? Oh, I missed the RC here. Right, so all of these now need, oops, RCs. So this is going to be a little bit of tedious code, but once we do it, it'll all be done. And then we can hash on the entry. Now all we're trying to do is save for every expression, right? We're just trying to save how many environments back we need to look. This primary one has a lot, doesn't it? And I was thinking, well, why don't we just store that when we're going through it? Why don't we store it directly in there? But there's actually an answer on that. SuperCuber says, why RC on the Expr variants? Because here's what I'm thinking, and maybe this is the wrong approach, but here's what I'm thinking is that we then be able to hash on the RC itself here, and then do pointer comparison here with the RC. And that way we can see if they're equal. Because all we're trying to do is see if the expression, we're not trying to see if the inside of the expression is equal. We're trying to see if they refer to the same variable. I'm trying to emulate the Java style of things. Okay, so this builds. We have 12 warnings, and that's because of why. We're never reading that. Oh, we're not using generate AST. Yeah, okay. So this might actually work if I put in code for this, right? And for quality, it's match self, other, Expr assign a. And then we can just say RC pointer EQ AB. And let me just do this just to see if this builds. Yeah, okay, so that's all we need for that. And then the hasher, I think I looked up how to do the hashing before. SuperCuber says maybe a box then. Yeah, a box is going to be, it's going to be a different one each time, whereas with the RC I can just clone the RC and they'll still be equal. Right, because it'd be pointing to the same referenced struct, I guess. Rust hash RC value. Hash. That's what I was missing. Yeah, that's what I was just looking at, and I didn't want to do that. Pointer hash. Can we just cast it to a usize and do a hash usize? Or a write usize on the hash? Yeah, this is what I was looking at. MrT Time, thank you for the raid. SuperCuber says, after this chapter, maybe you would want to look at my types and compare. I did a bunch differently. Yeah, so I bet you did it more rusty, right? Yeah, thanks again for the raid, MrT Time. What were you working on? Any rusty stuff or something else? All right, so I'm going to do this, and then we got to figure out the hash thing, and I think it's just this hasher business. We'll call this hasher, and each type will have to have its own, right? Match self, Expr assign a. It's going to be hasher right usize, RC as pointer, self, no a as usize. Let's see if that works. Yeah, so that compiles. MrT Time says, saw you were doing a Rust interpreter, so was interested. Yeah, so I've been doing this for a bunch of days now, trying to work my way through the Crafting Interpreters book, which is a really cool book, but it's all written, or at least the first half is in Java, so I'm trying to do it in Rust. You're doing a daily 1 hour coding power hour challenge. So sticking to Python for speed. Yeah, well, I mean, if that's the language you write the quickest in, you definitely should use that. It's ass? I'm sorry to hear that. What is the 1 hour coding power hour challenge? I'm not familiar with that. Oh, thanks, SuperCuber. Yeah, I'll definitely look at that. I think I had a link to yours, but I will. Let me pull it up now, just so I don't lose it. Oh, this was Mizzard's. Yeah, this is Mizzard's implementation of the macro. But okay, I have it here. I won't take a look yet until I'm done getting the resolver working. But thank you. Thanks for stopping by too. All right, so let's see if we can get our code generator to generate these bits of code here. So let's open up the code generator code and slip it in here. Where does it go? So this generates, here's where we generate the enum. MrT Time says a quick and dirty explanation of the power hour challenge is come up with an idea, start a 1 hour timer. Whatever state the code's in at the end of the hour is finished. If it's not working, it's not working. If it's unoptimized, it's unoptimized. It's interesting. Oh yeah, okay. I mean, for me, 1 hour would be spent just coming up with the idea and sketching out a design. So I would have zero code written after an hour. Okay, so this is the impl of the enum. Oh no, this is the impl of the enum. So let's put this in here. So I want to start with a partial equal. For Expr. And this will be base name. Epic Blog says 1 hour doesn't even cover the time to come up with a name for the project. Yes. Okay, do self, other self. But I guess you'll have a second power hour to work on the next bit of it. And this doesn't need, oh, this doesn't need anything. Okay, so we're good here. Right line file. Patch self another. Oh, and this is where we have to do the for T in tree types. Okay, right one. And this will be 0, 1, A, comma, 0, 1, B, right? I'm just following this pattern here. Close paren is RC pointer EQ AB, comma. MrT Time says, so far it's been really simple stuff. It was sanitizing user input with a blacklist and a whitelist to run code from a text file. Okay. Yeah, I guess if you already have in mind what you're going to work on, that's a good way to get started right away. And then we need, we will need the false to cover all the other cases. And then we just need to go close, close, close. Like this. And then for X. There. Okay, so that is, and then we'll just stick in an extra new line there, and then I can put this in here, impl EQ for Expr, and another extra new line. Like that. Okay, and then we want to do the hash. This is a little more complicated, but not that much so. Impl hash for Expr. Putting a question mark there is making it slow to type. Hash H self hasher mod H. I'll just put this all on one line, doesn't matter, hasher. And then file, I can go like that, and then we do the for loop. SuperCuber says Rust is love, Rust is life. Oh, sorry, I missed your question here. Anyway, have you been liking Rust? I haven't really touched it because whenever I want to go low level, I gravitate more to C++. So I tried C++ a while back and it didn't mesh well in my brain. And so I sort of just set it aside and said, this is for others. This is not for me. Let me put the match up here. So when Rust came along, this looks ugly, but okay. When Rust came along, I decided to give it a shot, and it works a lot better. Oops, that reminds me, I forgot these guys here. Base name and t.base class name. Yeah, when Rust came along, I gave it a shot, and it worked a lot better for me. So I was happy enough with it. So this takes Expr, assign. I said, okay, let me dive into it and really work on it. So I started about a year ago playing around with it a little bit, but it's really since October of last year that I've been doing it almost every day now. And I did it for Advent of Code, and I'm also working on this other Rust tutorial to make a roguelike, which looks like this. Which is kind of neat. You have a little roguelike that you can run around in the browser and play a roguelike game. And we're actually going to get to that next week. Get back to it next week. All right, so we're doing this Expr assign business here, then hasher, right, usize, RC as pointer, A as usize, semicolon, close brace. And this is going to take base name and t.base class name. Right? And then after that loop, we're going to put this guy here. I do nothing. Oh no, we don't have to. We shouldn't have to because we're going to have everything covered. Thank you for the follow, MrT Time. I think I can do this, and then this, and then this, and then this. All right, and hopefully that'll generate this. So what we can do is, let me save this off, copy source Expr, to a safe directory here, and then I'll rerun this thing. I have to modify the build script again to remove that, to get it to actually run, and now it fails. And it fails here because, oh, I forgot to put the RCs around these. Okay, that's an easy fix. Except I can't read it where it is in the code. Here it is, pub enum. So it must be this thing here. Almost. Oh, I forgot to close. Okay. There we go. 4 errors. What's this one? Impl hash. Oh, I need to, yes, I need to import those guys. Okay, so I guess I can just shove them up here. File, use standard hash, hash and hasher. Two errors. We're getting close. First implementation here. What? Well, did I do it in 2 spots? 35 and 33. Oh, I put Expr. Okay, so I have something hard-coded because this is in the statement file. That's what I did wrong here. Okay. Yeah, so this should be this, and I should put in base name. Did I do any others? Yep, here. So this should be this, and this should be base name. Any others? I can get rid of this comment. I don't need that anymore. Okay, so I think we're good now. 13 errors. Oh, right, because all of the statements need to be RC'd, right? I don't want that, I want this. RC new. RC new. Good thing we haven't gotten too far into this, otherwise this would be really painful. I think we're actually almost done, right? Yep. I mean, I'm done with the JLocks port. We got to be getting close to the end. We have all the statements in here. We're just doing this resolver business, and then, oh, we still haven't done methods and classes and things. Oh, thanks for stopping by, MrT Time. Sorry, I missed your comment there. Concentrating too hard on this. Okay, so we have 4 warnings, and that's okay. The wrapper is not used, local is not used, resolve isn't being called. So this we can fix, right? That's in the interpreter. We can change that back to that. Okay. And now I think we can actually dive into this. Now that we have something where our interpreter can now resolve, can actually insert these RCs into this thing. So I think we're good. So where did we leave off though? Visit assign Expr in resolver. Oh, we should yeah, we're gonna need this soon, and I commented out because it just was causing a warning, but I don't care anymore. So let's commit these changes. Oh, git status, git and generate and source, git commit. Okay, refactor Expr and statement to keep reference counted variables for the resolver. There. Okay, so now let's take a look at the resolver. Did we do assign? We did not do assign. We did resolve local. Okay, so that exists. Fn resolve local. Yeah, so that was what we got to, and then everything broke. So now 11.3.4 is visit assign Expr. So let's do that. This hopefully will go faster. So self, resolve, and we have to say resolve Expr, right? Because we can't do function overloading, and then we just get rid of this underscore here, and it's going to be Expr value. We're going to say self resolve local. Oh, and this is the wrapper with Expr name, and it's just okay. Okay. Yep, so that's all we have to do. So the other expression that references a variable is assignment. Resolving one looks like this. We resolve it and resolve local. So first we resolve the expression for the assigned value in case it also contains references to the other variables. Then we use our existing resolve local method to resolve the variable that it's being assigned to. Okay, now we resolve function declarations. Finally, functions. Functions both bind names and introduce a scope. The name of the function itself is bound in the surrounding scope where the function is declared. Okay, yep, I understand that. When we step into the function's body, we also bind its parameters into that inner scope. So when we visit a function statement, we do a declare, a define, and then a resolve. So that's here. Self declare, statement name. And we're going to have to do a wrapper here. A self-define statement name, and then self-resolve function, which is something new, and that just takes the wrapper. Oh, it doesn't take the wrapper. It takes the wrapper and the function params and the body. So it takes everything. Okay, statement. And now we have to write that. So it's similar to the visit variable statement. We declare and define the name of the function in the current scope. Unlike variables, though, we define the name eagerly before resolving the function's body. This lets a function recursively refer to itself inside its own body. Then we resolve the function's body using this. Okay. And this is going to be a statement, a wrapper, which is RC statement, and then a statement, which is going to be whatever got passed in. It's a function statement. And it doesn't return anything. Okay, so self begin scope for param in statement. I guess we're calling it function here. So we'll just use consistent naming. Params. Self declare param. Well, this probably needs to be this, right? And then self-define, and then we're done. And then we resolve. And we're going to resolve the body, which is the statement. So we have to say self-resolve statement, function body. And then self and scope, and we're done. So we don't actually need the wrapper, right? What does resolve calls resolve statement calls accept. So we don't actually, we don't need the wrapper. So let's pull that out. Which means we don't need it here either. Okay, let's see if that checks. It does. It's a separate method since we will also use it for resolving locks methods when we add classes later. Okay. It creates a new scope for the body and then binds variables for each of the function's parameters. All right, so I don't know. I can't run this and test it out to see if it's working. So I guess we'll just carry on. Once that's ready, it resolves the function body in that scope. This is different from how the interpreter handles function declarations. At runtime, declaring a function doesn't do anything with the function's body. Nerodes, thank you for the follow. The body doesn't get touched until later when the function is called. In static analysis, we immediately traverse into the body right then and there. So that's what this is doing. All right, resolving the other syntax tree nodes. That covers the interesting corners of the grammar. We handle every place where the variable is declared, read, or written, and every place where the scope is created or destroyed. Even though they aren't affected by variable resolution, we also need to visit methods for all the other syntax tree nodes in order to recurse into their subtrees. Sorry, this is a bit boring, but bear with me. We'll go kind of top down and start with statements. I did say the book would have every single line of code for these interpreters. I didn't say they'd all be exciting. Yeah. All right. An expression statement contains a single expression. So I guess we start here. So just self.resolve statement expression. An if statement has an expression for its condition and one or two statements for the branches. Nero says, C++ developer deep into Rust. Awesome stream and YouTube videos. Keep it up. Thank you. Thank you. I hope you're enjoying Rust as well. So expression statement we did. So now if statement. Where is if statement? Here it is. Self-resolve statement. And self-resolve statement. Then, statement. Then branch. And then if let some else branch equals statement else branch. Self-resolve statement else branch. How's that? Does that compile? Is this working? I'm getting nervous now. Oh wait, maybe I turned this off. I did. Okay. So we haven't been actually doing any of this. We have 28 errors now. Wonderful. That we can fix. Yeah, I knew something was going wrong when nothing was breaking. All of these need to be RC'd. SuperCuber says, oh no. Yeah, oh no. Hopefully this will go pretty quickly. New. Not new. What am I doing? Like this. I'm going too fast now. You know what I can just do is this way. Why not a statement like that? There we go. And then I can just hit the dot. Oh, and this is Expr, so RC Expr. Dot. Dot. And this is a typo. And this saying what? Expected a slice found struct RC. Oh. So I can do it that way. And RC is not found in the scope. Oh, really? Did I put an ampersand in front of there? Okay. Isn't that going to break everything, though? I thought I didn't put ampersands. And then it doesn't like this. Expected enum struct statement found RC. Oh, so these resolve statements now need RCs. Oh, yeah, see, this is why we can't have... Oh, condition is an Expr. Okay. Found struct RC vec RC statement. Okay, we can fix that. SuperCuber says, can't you transform RC into ampersand T? I'm not sure what you mean. I mean, are you talking about putting a T on here like that, and then, or making a separate type for it, like type T equals RC statement, or something like that, and then putting T everywhere? Maybe that would save a lot of typing, I guess. But now I need to change resolve to take statements like this. RC vec RC statement. There. Expected. Okay, so now we do the borrow. Expected vec. Oh, this has to be resolve Expr. Oh. SuperCuber says, no, I mean just ampersand myRC can be used where an Expr is expected. I'm afraid I'm still not getting it. I'm not as rusty as you are. Sorry. All right, so we have this problem here, but I also see this issue where accept now needs both the wrapper and Let me take a look at what that looks like. Source Expr. It takes the wrapper, which is the RC Expr, and then the visitor. Oh, so we just had to pass in a statement here, and then the Expr here. And this is an RC Expr. SuperCuber says, I'll try it and report back. Okay, good, because I'm a little lost on what you're suggesting. Uh-oh, now line 177 is broken. Okay, let's fix this one here. Maybe I can deref this. And we have a play rust line. Let's take a look. So this is creating a RC of of a string, and then just passing that in and allowing Rust to do the deref for us. But that would mean that, oops, I was typing over there. That would mean that we should be able to just put, for all of these guys, right, I should be able to get away with this. And it wasn't letting me compile that way, because I was expecting the function signature to match what we have in. Oh, do you mean down here? These don't need to be RCs. Maybe they don't. This is expecting an RC though, in our accept. So if I put it here, yeah. SuperCuber says, I think RCs and functions args is almost always wrong. You're probably 100% right there. And what, the only thing is, so here's what I'm stuck on, right? In the interpreter, when we resolve locals, here, I want to be able to hash on that RC Expr, on the RC for the Expr. So the only way to pass that in is this way. And I have to pass them all around. Right, because this derefs the RC, and so we no longer have access to the RC anymore there. And so if I did it that way here, that wouldn't give us the same reference count. I'm definitely going to take a look at the way you did it, SuperCuber, once I've gotten it done. And there's probably a much faster and simpler way to do this. So let's see, what does this do here? We still have the issue of the what isn't like that? Okay, you know what? There we go. Cargo check. So here's our first error. We're not passing in. Oh, this needs to be RC. And then we have this here. This, and now wrapper doesn't work. Oh crap. Yeah, so maybe these don't. Okay, so let me take a look at our generator and remove the ampersand from that, which means changing all of the code everywhere. That should be pretty simple to go through. And if this breaks everything, then I'm going to cry. Actually, the practice one for F1 is going to start in about 10 minutes, so my brain is a little distracted by the fact that I'm missing that. Oh, and then this. Oh. And that means generate. And wrapper. Here's wrapper. Here. Okay. So let's get rid of those guys. And then I guess we can get rid of those guys as well. We still have 9 errors. Oh, No, it doesn't like it. Oh, because I don't have deref at the top here. Okay. Still doesn't like it. Oh, found found statement. Expected RCO. Okay. But it didn't like it this way either. Can I do this? Nope. Okay. And then it's going to complain about moves, right? That's what's going to happen. Right? Because we can't... Oh, maybe I just clone them. Oops. Yeah, I think that's what I need to do. RCVec token is not an iterator. Isn't that why I'm dereferencing it though? How are we supposed to go through the parameters if they're all broken like that? This wasn't supposed to be this hard. Slap an ampersand on it. Yeah, if I do that, no, it doesn't like that either, right? It's saying RCVec token is not an iterator. So we have to pull the... I mean, is it doing it wrong? It can't be doing it wrong like this, right? I'm trying to deref the... RCVec token is not an iterator. Do I have to deref this thing? I guess so. This should just be resolved, right? Because we're resolving the whole function body. Expected reference found in RC. Slap an ampersand on it. These two go away in the interpreter. And now we're down to 20 errors. Function params iter is the way. It should auto deref. Yeah, it seems to be okay, but yeah, now we're going to have issues with moving and stuff. Oh, Burrow Singh, thank you for the follow. Yeah, but now everything else is broken because I have all of these RCs everywhere. Oh, this value here is expected RC, found RC Expr like that. And if I do this, it's going to complain. I swear it's going to complain about moving. And I might have to just put clones everywhere. Because we would be cloning the RC. Right, so once we get this to all compile, and down to 6. Yeah, and then we have this issue here inside this iterator. Expected RC found reference to RC. Okay, this is where I get into cloning, right? One more. And then what's going to happen is we're going to say we're going to have errors with moving. Yeah, move occurs everywhere. Okay, so the clones work. But this is really painful, isn't it? How many are there? 22. Yeah, this is definitely the wrong approach. So I'm going to have to revisit all of this. What we should do actually is write a bunch of tests to make sure once we have it working, get it working, and then we can refactor everything. So that we don't have to do all these clones everywhere. What we're cloning is the reference counted pointer, so I'm not that bothered by it, but it's still annoying that we have to do this. There's got to be a better way. Okay. We still have 8 warnings though, and we have results that need to be used. Okay, so line 45 in the resolver, which means we put a question mark there. Line 46, we put a question mark there. 48. I forgot that that thing needed question marks. And then 61 and 86. And then 188. One error. Oh, this one doesn't take it? Okay. Right, so we're not calling resolve and are creating it. Okay, so we have something. I have no idea if this works. If I say cargo run, what do we have for locks here? Cargo run block. Because that uses scope. It still works. It still works. All right, let's finish up this section here and then see if our resolver does resolution. All right, so visit if statement's done. Print statement now. I'm going to say self resolve statement condition. Oh, this has to be resolve Expr. And then we have self resolve statement then branch clone. Oh, we have to clone the other guy too, right? SuperCuber says, I don't think you're using scopes yet, so behavior should be the same. Yeah. I just want to make sure I didn't break the interpreter, right? Because we did a whole bunch of changes. Wait, what am I doing? I'm looking up here and supposed to be doing this. Okay, just that. That's all print statement is. Same deal for return. So return statement is copy that line. Where's our return statement? Paste. And this is just value. Oh, we have to say if let some value equal statement value clone. Resolve statement. Oops. Value, like that. There, okay. If statements, as in if statements, a while statement resolve its condition and resolve the body exactly once. Condition clone, and then self resolve statements. Oh, body. Okay, so and then we have to change this here. I forgot about these guys. What doesn't it like here? It doesn't like value. Oh, so this is just a resolve statement. It's just a single statement for the body. I keep doing that. And then the condition is an unknown field because why? Oh, not on print statement. Print statement just has expression. I was still stuck on the if statement there. Okay. And then binary Expr. We're going to evaluate left and evaluate right, and then we're done. Resolve Expr. Expr left clone. And right. Okay. And then call Expr, which is here at the top for some reason. Self-resolve Expr. Expr call E clone. And then 4, and then we have another for loop here. So similar to this. No. Is there another one we can copy? I don't think so. All right, we're going to try it. Argument in Expr arguments clone or iter. Let's see if that works. Self-resolve argument. Nope. Oh, this. Expected evec. Oh, right, because it's resolved. This is Expr. And expected RC found ampersand RC. Clone. Done. Okay. Parentheses are easy. So this is the grouping Expr. Right, and then literal is easiest of them all. We don't do anything, so we already have that. Okay. A literal expression doesn't mention any variables and doesn't contain any sub-expressions, so there's no work to do. Since static analysis does no control flow or short-circuiting, logical expressions are exactly the same as the other binary expressions. So I guess we can just copy-paste. Or we should have a single function which does all of them. And then unary, which just has a right and no left. Oops. Like that. Oh, I forgot to change the variable name. There we go. With all of these visit methods, the Java compiler should be satisfied that the resolver fully implements statement visitor and Expr visitor. And I think, so yeah, I should just double check to make sure there's nothing missing. And this new should go down here in the main section. I don't know why I had it as a separate guy up there. Okay. So this should check. Yep. So now interpreting resolve variables. So this is 11.3 done. Let's see what Clippy has to say with this disaster of a... Oh, all of these can change. That's easy to fix, right? Generate mod, and then all we have to do is wrapper ampersand b. Look for that line. Yeah, and just remove the ampersand. Well, okay, that still compiles. So we just have 5 warnings now. New is not used. Okay, this toString doesn't need to be done. Oh, right, because I fixed that. I fixed that a while back. All right, this just needs to be closure. Doesn't that also mean these don't have to be like this? No? Okay. And then we have an unused result. Okay, so that's in resolver. And 206. Doesn't like that though. I'm not sure why. So if I put a, oh, I know why. Duh. So this is a result of something or locks result. That's why. I wasn't paying attention. I think that's what we need to return, right? So let's put a question mark there. Oh, because I forgot the OK at the end. Okay, so 3 warnings now is that new and resolve function aren't used. And I think that's what we're going to get to next, right? Yeah, okay, good. So let's see what our resolver is good for. Finally, all that work. I just want to take a quick peek. See how things are going here. There's probably nobody on the track yet. They always take forever to get on the track. Oh, I don't want to play it. That would be illegal, wouldn't it? All right. So I'm just going to keep this here. All right, and I'll keep taking a peek. SuperCuber gives me a PogChamp. Thank you. Okay, so let's see if this actually works, right? Each time it visits a variable, it tells the interpreter how many scopes there are between the current scope and the scope where the variable is defined. At runtime, this corresponds exactly to the number of environments between the current one and the enclosing one where the interpreter can find the variable's value. The resolver hands that number to the interpreter by calling this. Yeah, so we added this because that's where we went into this abyss of trying to figure out how to get a reference into the resolver, into the interpreter to resolve in the locals. We want to store the resolution information somewhere so we can use it when the variable or assignment expression is later executed. But where? One obvious place is right in the syntax tree itself. Right, so that's what I was thinking before. Why are we going through all of this work if we can just store the data for the resolution directly in the node, right? So each node that had a variable lookup, right, the Expr itself would contain, okay, how far back do I need to go? Like a pub, left, distance, new size, right, and then a right. And we would just store it right here in the node when we did the resolve. SuperCuber says, I did that. Oh, okay. So maybe that's the right approach, but okay, let's keep reading. We could do that, but it would require mucking around with our syntax tree generator. Instead, we'll take another common approach and store it off to the side in a map that associates each syntax tree node with its resolved data. I think I've heard this map called a side table since it's a tabular data structure that stores data separately from the object it relates to. But whenever I try to Google for that term, I get pages about furniture. Yeah, okay. Interactive tools like IDEs often incrementally reparse and re-resolve parts of the user's program. It may be hard to find all of the bits of state that need recalculating when they're hiding in the foliage of the syntax tree. The benefit of storing this data outside of the nodes is that it makes it easy to discard it, simply clear the map. That's, yeah, okay. That doesn't apply here, right? Because we're never revisiting the tree. Once we've done the interpretation, the parsing, the interpretation, we do the resolving, we're done, we execute it, and then we're over. We don't have to keep... Yeah. All right, well, we've gone through all this work. SuperCuber says it's just easy in Java, but hard in Rust. Yeah. Okay, so I'm gonna not do this because this is generated code. So we did this already. You might think we need some sort of nested tree structure to avoid getting confused when there are multiple expressions that reference the same variable, but each expression is its own Java object with its own unique identity, right? So that's what we just went through the exercise of making with all those RCs. A single monolithic map doesn't have any trouble keeping them separated. So we did this. Accessing a resolved variable. Our interpreter now has access to each variable's resolved location. Finally, we get to make use of that. So I should be able to dump that out before we start interpreting, right? Oh, we're not even using this yet. We're not even calling the resolver yet, right? So we got to figure out how to link it in. But we have this visitor variable Expr in interpreter now. So instead of doing this, all right, before I do anything, let's get these changes committed. Resolver, mostly, done. The reason I put mostly is because we're still making changes to the interpreter and apparently into an environment as well here. So let's see how this goes. All right, so in our interpreter, visit variable Expr, we're going to return something called lookup variable. So instead of this guy, it's going to be expr.name and then this wrapper, which is the actual reference to it. And this takes this here. So we're going to have in our interpreter, I guess it doesn't have to be pub, right? Look up variable self, name is going to be token, and Expr is going to be an RC of Expr. And it's going to return an object. Or, yeah, it's going to return an object or a logs result if we can't find it, I guess. Locals, borrow, get, Expr. Yeah, get. And we have to say if, let some, because it might not be in there. Right, because this is looking up in the hash map. And that's where as distance is not equal to null, we'll do the environment, otherwise we'll grab it from the globals. Which also needs to be checked for null. Right, if let some value equals self globals borrow get name as string. Right, I think that's what it is. Oh, that's from the environment. Yeah, okay. So that already returns a logs result. So we don't have to do that. Okay, so if we were able to find it in the locals, then we're going to return the environment get at. We always have to do double borrow get at distance name as string. This isn't globals get name, but this is name lexeme, which is how I use this as strings. So all right. Well, let's see. What does this do? Token is not found in the scope. And Expr expected reference found struct. And this needs to be ampersanded. and get@, doesn't exist, right? So that's what we have to do. There's a couple things going on here. First, we look up the resolved distance in the map. Remember that we resolved only local variables. Globals are treated specially and don't end up in the map. So if we don't find a distance in the map, it must be global. Sorry, I'm taking another quick peek here. Go Lando. All right. In that case, we look it up dynamically directly in the global environment. That's this line here. That throws a runtime error if the variable isn't defined. If we do get a distance, we have a local variable, and we get to take advantage of the results of our static analysis. Instead of calling get, we call this new method on environment. So we're going to create a new method on environment, and we'll call it get@. And it's going to take a self, a distance, and a string name. So name string. And it's going to return result of object or box result. And then we're calling something called ancestor. Okay, I'll just throw that in there and then we'll have to figure out if that's going to actually work. So ancestor must be a new method, right? The old get method dynamically walks a chain of enclosing environments, scouring each one to see if the variable might be hiding in there somewhere. But now we know exactly which environment in the chain will have the variable. So we'll reach it using this helper method. All right, so we'll make a ancestor, takes a self and a distance, and returns an environment. Really? Okay. So environment equals this. Self. And then we're going to back up for each one. And we're going to grab enclosing, but enclosing is an option RC ref cell environment, which means this needs to be an RC ref cell environment. So that I can say environment is equal to environment dot enclosing dot unwrap. SuperCuber says, I think I did this recursively. Same thing. Oh, yeah. Just call it with distance -1 each time. Yeah, that might be a simpler way to do it, right? And then we'll just return. Let's see if this works, and maybe we'll try it the recursive way next. Yeah, it doesn't like this. Environment. Because I don't know how to spell words. It doesn't understand. Oh, borrow. So does this need to be a reference? Right, so we're expecting a reference here, expected reference. Oh, I see. There's ampersand environment in there. That's the problem. All right, so what we can do is say if distance equals 0, return self. Otherwise, we can go environment borrow. Oh, unwrap, borrow. I was enclosing, unwrap. And then distance -1. Nope. Self. Should I return reference? That can get us lifetime issues? Oh, right. And then we can't do that because this is environment and found in RC. So borrow. And of course you can't borrow it like that, right? Really? Okay, that worked. It compiled that. And let's take a look at what the recursive version would look like. It might be simpler. Pub fun ancestor self distance usize environment. If distance equals 0, return self, else self ancestor distance minus 1. Yeah, so compare these two. This I like your approach a lot better, SuperCuber. But we have an issue here down in this. We're expecting because we're supposed to be returning this, and it found an option instead. So we have to do an unwrap. Okay. Oh, self-enclosing ancestor. You're right. Thank you. Unwrap. There. Expected use size found use. Well, this is one place where we can just do that. Wait a minute. This is on interpreter line 333, expected use size found use size. Okay, I can fix that. But what's this one here? Expected enum object found reference to object. Oh, I do clone it out, don't I? Okay. And so this distance just can do that. And then name expected stir found struct string. Okay, so that's straightforward. And this same thing? Nope. Expected token. Oh, this, yeah, so this was supposed to be a token. Okay. Uh-oh. Move occurs because self-enclosing has this type, which does not implement the copy trait. So we have to put an as ref in here. I remember having to do that before. Okay. And it still is not happy because returns a reference to data owned by the current file. Yeah, you can't borrow in the middle of that. Okay. And that is going to be the same issue here, even if I don't do it the recursive way, because we're borrowing and returning the borrowed reference. It's going to complain about that as well. All right, so this is something I'll have to dig into. Quick peek again. Max, of course, on mediums. Where's Hamilton? Did I miss him? Oh, here he is. Okay, he's on mediums too. Charles on fourth on hard tires. Nice. Okay. Sorry, I get distracted. All right, so what do we have to do? I don't want to clone the whole thing, right? But obviously I can't return a borrow. Oh, it's an RC. I can clone the RC, right? If I return that. I should keep a counter of how many times I hit F1 by accident. If I do that, Maybe return an RC, yeah. The only issue is this guy here, which we could just put in here, right? If distance equals 0, then self values get name as string, unwrap, clone, else. We'll go the distance there. So that should never be 0. And then we can just return the environment. And then nope, it doesn't like that. Oh, it already is a string. Unknown field on ancestor. Oh, borrow here. That's where the borrow goes now. So we need to unwrap, clone it, right? Yeah. And same here. Nope. No. Yeah, because we're borrowing it here, we can't just save the value. So we didn't really solve the problem at all. We have this, right? So let's take a look. Because we should be able to do this, right? We have an environment, let's delete that. So the current environment is going to be the new environment. It's going to be the current environment's enclosing. Unwrapped, cloned, right? We don't need to borrow anything. Right, we're just cloning this RC after unwrapping it, and then that's what we're going to return. And it still doesn't like it. Oh, environment. Oh, I do, because this is an RC ref cell. So I do need to borrow there, and then that's going to complain that the borrow can't work because it's a temporary. The way ref cells work is they're just temporary borrows. SuperCuber says I had get at called the enclosings get at. Okay, let's try that. That would be using this guy here. This would be unwrap get at. Oh, not down there. Down here, we'd say self get at distance -1 name. And that's going to return a result object. So we can just return the whole thing like that. And that way we don't have an ancestor. What's that going to break? That works. Okay, that's probably the simplest approach. Yeah, I agree that we don't need ancestor at all in this case. I wonder if we'll get if that's going to hurt us later. If we need ancestor later. All right, but this works. We do have 3 warnings. Yeah, and that's the same warnings we've been getting all along. No worries. Let's get rid of those guys. That's the ancestor. Alex, thank you Thank you for the bit. And oh yeah, it's a Shamrock bit. Very nice. Happy St. Patrick's Day to all. All right, so the way the interpreter assumes a variable is in the map feels like flying blind. The interpreter code trusts that the resolver did its job and resolved the variable correctly. This implies a deep coupling between these two classes. In the resolver, each line of code that touches a scope must have its exact match in the interpreter for modifying an environment. Oh, the International. Thank you for the bits. I should set up little bit sounds. I haven't done that. I keep meaning to, but that's work. I felt a coupling firsthand because I wrote the code for this book. Because as I wrote the code for this book, I ran into a couple of subtle bugs where the resolver and the interpreter code were slightly out of sync. Tracking those down was difficult. One tool to make that easier is to have the interpreter explicitly assert, using Java's assert statements or some other validation tool, the contract expects the resolver to have already upheld. Okay. So this code here, ancestor walks a fixed number of hops up the parent chain and returns the environment. Once we have that, getAt simply returns the value of the variable in that environment's map. It doesn't even have to check to see if the variable is there. We know it will be there because the resolver already found it before. In our code, it's already there in the form of unwrap and expect. Yeah, so our unwraps are going to fail with a panic, right? If our resolver and our interpreter get out of sync. Okay, so assigning to a resolve variable. We can also use a variable by assigning to it. The changes to visiting an assignment expression are similar. All right, so let's go to our interpreter. Oh, let's commit these changes. Before I break anything else. So in visit assign, we're going to do this. If distance is not equal to null, then we're going to do in variable assign at. Okay, so we have the value. We say let distance is equal to self locals borrow get Expr. I guess unwrap. Oh no, we're going to say if let sum, just like we did before, and no unwrap. If that's true, then we're going to say self. We're going to do this. And we're going to call assign at distance. Else, we're going to assign to global self globals borrow mut assign Expr name and value clone. Oh, question mark goes outside and return the value. Okay. So this should compile except for assign at. I forgot the borrow. What? Is locals not a ref? Yeah, locals is a ref cell. So I do need to borrow it. What is this saying? Oh, I'm passing in the wrong thing. I have to pass in this thing. Wrapper. Okay, and now assign at doesn't exist, right? So that's what we're going to write next. So in environment, we have getAt and get. So now we just need to put assign at. What are we doing? Name is going to be a token, and the value is going to be an object. and it returns nothing, locks results. Okay, so for assign at, here's where we need ancestor again, but we can do the same exact thing here. We can say if distance equals 0, self borrow. Oh, this is doing this is checking to see if it exists, but it shouldn't. We shouldn't have to worry about that. Assign name value. Else self assign at. Oh, this should be in closing. Unwrap. Right? And this has to be the same thing here. Self in closing assign at. Unwrap. Assign at distance -1, name value. And this doesn't work because what did we unwrap? We unwrapped this option. Oh, we have to do a borrow. Oops, where am I? And this needs to be a borrow mute. Values assign. Oh, not assign, right? Put, insert. Name as string, value. Oops. We have to clone it. No, it still doesn't like that expected result, so this is going to be... Oh, yeah, can this fail? Expected unit type that, found option object. Oh, it's returning the object, I see. What are we doing here? Are we just doing insert and then an OK? All right, we still have 2 errors though. Distance doesn't... Oh, we have to do that. Yeah, and so we have to do that. 3 errors. And this is because now we have issues. Move occurs, right, and we have to add the asref. Two errors. Assign that should take an object, not an object. Oh, so we don't have to clone it in there? But it's going to have to get cloned into here, right? I mean, I can try it. Oh, this should be a mutable reference, right? That's what we have for assign, right? Yeah. Self-enclosing as ref. And then it doesn't like visit assign Expr returning the value because we used it here. Oh, we do have to clone it because we're returning it. That's right. Oh, CDE compilador. Compilador? Thank you for the follow. All right, so we're up and running. Thank you again, SuperCuber, for the assistance there. So this looks good. It's compiling. Who knows if it works? Those are the only changes to the interpreter. This is why I chose a representation for resolved data that was minimally invasive. This was the opposite of minimally invasive. Ugh. Okay, so now we're going to get to run it and see if it actually does anything. So in our code, before we call interpreter interpret, so it's down here. Oh, you know, that's the thing. We're not checking to see if there's any errors with our scanner or anything else. We probably should add that in, right? Because scanner has a had error. Oh no, it doesn't. The parser has a had error. Yeah, so I should be checking to see if it had an error. Oh, I do. I have a success thing here. Yeah, parser success. Okay, so we have that. If the parser succeeds, then we'll say let resolver is equal to resolver new self interpreter, and then resolver resolve statements. We don't have resolver in the scope, so let's pull it in. I should delete all this AST printer business. Get rid of those files. Oh, did I forget to make it pub? Yeah, I did. Oops. Expected struct interpreter, help consider removing the bar. Oh, I think I don't want to pass the I don't want to move the interpreter in, right? Oh, but then that's going to end up causing issues here. If I do that, it's going to move it. Oh, that's a private associated function. Now it's public. Expected RC found vec. Expected reference RC. Oh, we can just say RC new, right? I don't know if I need the ampersand there or not. RC is not part of the scope. Use standard CRC. Yeah. So now this move happens here, and now we can't use it down here. So, and I'm getting antsy because I don't want to have to tick A everything. Because if I do this, then we're going to have to, yeah, so this needs an A, which means this needs an A. And so does this. And this needs to be like this. Oh, maybe this will work. Oops. Okay, so this is moved here. So maybe I can say let S equals RC new statements, and then say RC clone S. And then this, I'll have to do the same thing. And then pass those in as an RC vec. Okay. Does that work? We still have this issue here. Oh, we have an unused result that must be used. That's here. And then in resolver, we have this resolve function which must be used. So ooh, look at that. We're down to 0 errors and 0 warnings. Okay, now I'm going to see if this actually works, or if we just broke everything and I'm going to go off and cry somewhere. Let me just take a quick peek. The session's almost over. Oh, Gasly, nice. Nice. Okay, sorry. Cargo run block. Because this is going to use, yeah, okay. So we have issues that we need to fix. SuperCuber says it compiles, therefore it works. Yeah, I wish that were true. I think there's a logic error in where is it? Because I rehacked the code that does the loop to calculate the distance back. Where is that? This code here, resolve local, which I think is what's broken. So, because it's playing with this thing here about scope size -1 greater than or equal to 0, and the way I did that was with the rev. I think this needs the same kind of idea. I'm going to say let len is equal to self scopes borrow len, right? Because then I think this needs to have len. So this is going to go. Yeah, no, this is the right order, right? We enumerate after we reverse it, so we should be putting it in the right scope. Println resolving Expr at scope, right? That should. Oh, Expr can't be formatted that way. Can I format it as display? Did I add that? I probably didn't add that. No. And printing this, adding debug to this will be painful. Especially given the fact that I only have 10 minutes left. All right, so I think this is where the bug is. It's that we're not resolving the scope properly. I can at least print out. To do. All right, I can print that out and we can see what we're doing. Resolving to do at scope 0. So it wasn't able to find. Okay, and we can take a look here. Resolver line 123. Oh, we're visiting a variable Expr and we're not able to unwrap it properly. So visit variable Expr. That's in the interpreter. And here in the resolver. So if it's not empty, and so scopes.peak is this self scopes borrow last. Unwrap, we'll borrow again, and then take a look here. What I can do is when we get here, I can print this out, right? And I should be able to print the scopes, right? Because it's just a map. Let's see if that works. Yeah, okay, so let's take a look at what that prints out. So our current scope is a ref cell with value A in true and B in true, and another ref cell. So must be the next scope with A is true. And we don't know what we're trying to look up, but we can guess. Blah. Right, so we set A, B, and C as globals, so they don't show up in the scope. Then we have A and B, which are here and here, and then A, which is here. Now we're trying to resolve this A one back, and it should be there. But we're doing an option unwrap on a none value, which is not good. It's saying that Expr name as string doesn't exist in this map. Println looking up. I probably can just do this, right? That way we'll see the whole variable. Yeah. Looking up identifier B. Oh, it's looking up B in the last scope. Oh. What does this do if it can't find it? In Java, this get must return null or something like that. So then it wouldn't compare to Boolean false. So maybe that's what we need to do, which we have to be able to say if let sum found is equal to this mess. If it's equal to this mess, then that, else, we have this error. If not found, then we do this, same exact thing. Okay, I need to clean the code up, but I just want to get it working. We'll get rid of the duplicate else resolve local, self resolve local. Okay, this needs to be cleaned up. If do thing equals some false, maybe. Oh. Yeah. Okay. That should work. Okay, I can ampersand the false there. All right. Yay! Okay, thank you, SuperCuber. That was a brilliant suggestion at just the right time. Okay, so let me get rid of those printlns. Make sure I didn't break it. Okay. Oh, we still have another one. That one there. Good. Okay, so we got to this point here where we can actually run it and resolve variables and stuff like that. We do need to add the code for resolution errors, which I will save. So we finished section 11.4. Okay, and I'm going to keep this tab around, but I'm not going to peek at your code just yet. And let's take a look. One more check here on Pierre, still at the top of the timing charts. Nice. Max is down here. Hamilton's down here. It's just FP1, so you don't know what they're doing. You don't know what they're running. Qual is the important thing. Okay, let's push these changes up and call it a stream. All right, thanks everyone for hanging out with me. I really appreciate it. Let's go over and Let me pause my music. And I'm going to pull up Toggle because we can go raid him. There we go. So let's go raid him. And then next week, we're going to switch back to the roguelike tutorial. We're going to start in the mushroom forest and see how far we can get with that. That should be a lot of fun. All right. Let's generate this raid here. All right. Have a great weekend, everyone. And I will see you Monday with the roguelike. All right. Take care.
Probably need that as well, don't we?
Hurrah for the sub!
Thank you very much for that, scientist. How you doing, buddy? Thank you for the sub. Thank you for supporting the stream. That could be doable. It would be super annoying with the text because it would keep like realigning and relaying out the text every time. But it would definitely be doable, right? Although that's an interesting one, Joe. I haven't thought of. I have we have mouse. Actually, that's not something that I would have to implement. But implementing mouse over would be reasonably easy, right? When we get a mouse event, we just look at the child underneath the cursor. But that's one thing I haven't implemented yet. But it's on the to-do list to find the child under the cursor. And the difficulty there is that we have multiple children under the same cursor, right? So you have a cursor that has the root, the parent, and then the children, all the way down to the actual child, right? So it's a little bit difficult finding which one you're actually looking for, kind of thing, right? Luckily, with